Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for finding k pairs with smallest sums. Let's look at the problem description. We are given two integer arrays nums1 and nums2 sorted in non-decreasing order and an integer k. Okay, and we have to return a k pairs with the smallest sum, and each pair is formed by picking up element u1 from the nums1 array and v1 from the nums2 array. Okay, let's take a look at the example 1. The nums1 array has 1, 7, 11 and nums2 has 2, 4, 6, and we have to return 3 pairs with the smallest sum, and in this case we can form a pairs 1, 2, 1, 4, 1, 6. These 3 pairs give the smallest sum. Okay, so that's why the output is 1, 2, 1, 4, 1, 6. And in the case of example 2, the nums1 array has 1, 1, 2 and the nums2 has 1, 2, 3, and we have to return 2 pairs with the smallest sum. So in this case, pair 1, 1 and 1, 1 gives the smallest sum among the other pairs. So the output is 1, 1 and 1, 1. The constraints for this problem are the nums1 and nums2 arrays length is ranging from 1 to 100,000. and the individual numbers value is ranging from minus 10 to the power 9 to 10 to the power 9. And the nums1 and nums2 both are sorted in non-decreasing order, and the value of k is ranging from 1 to 10,000. Okay, and k is less than or equal to the product of the length of the nums1 array and the nums2 array. Let's look at the approach to solve this problem. So we are given the nums1 and nums2 array. The nums1 has 4, 7, 11 and the nums2 array has 1, 2, 6. We have to return 3 smallest sum pair. So in this case 4, 1, 4, 2, 7, 1 are the smallest sum pair. So that's why the output is 4, 1, 4, 2, 7, 1. Okay. So the brute force approach is we create all possible pairs using the nums1 array and the nums2 array. So basically for the size m and size n, we can get m times n number of pairs. So in this case we create 4, 1, 4, 2, 4, 6 and 7, 1, 7, 2, 7, 6 and 11, 1, 11, 2, 11, 6, 3 pairs, totally 9 pairs. Okay, and this array has the sum of the individual pairs. Okay, so 5, 6, 10 and 8 and 9, 13, 12, 13, 17. We have to return the 3 smallest sum pairs. So in this case this is not in an ascending order, so we have to sort this array. So we get 5, 6, 8, 9, 10 and then we can return the first 3 elements in this array as the output. So in this case we have to calculate all possible pairs sum that have a complexity m times n. Okay, and then we have to sort that m times n number of elements, so which has m times n times log m times n time complexity. Okay, but if we use the minimum heap data structure, we don't have to compute all possible pairs sum. Instead we have to compute only the k plus 2 pairs sum. So the idea is, first we initialize the heap with the first pair, because the array is in a sorted order. So the first elements in both the arrays, the sum of the first element in the both the array yields the smallest sum, right? So first we push 4, 1 into the heap. Basically this node has the sum and then the index in each array. For example, in this case 4, 1, so the sum is 5, and this is the pair that has the index of the elements in array nums1 and array nums2, so 0, 0. And also we need a hash map to mark whether that particular pair is already included in the output. So we are marking 0, 0 as true. Okay. Next we pop the element from the heap and then read the element at index 1 and index 2 and create this slice and add it to the out list. Once that is done, next we have to find the next smallest sum. From these two indexes, the next possible smallest sum could be either the same nums1 index and the incremented nums2 index, or the same nums2 index and incremented nums1 index, right? So basically the first pair 4, 2 gives the sum 6, which is next smallest sum, and then 7 plus 1, 8, right? So we create a node for the pair 4, 2 and 7, 1, and then push that into the heap. Okay, so because this is a minimum heap, the root node always has the smallest number node. Okay, and also in addition to adding it to the heap, we have to mark those pairs as visited. 0, 1 is set to true and 1, 0 is also set to true. Okay, then we repeat this each time we pop up the node from the heap and then add it to the out list. So in this case we add 4, 2, 0, 1. So 4 and 2. So we add that to the out list. And then we compute from 0, 1 what is the next smallest pair. So in this case 0, 2 or 1, 1. Those two pairs are the next smallest number. So that's why we add 10, 0, 2, 9, 1, 1 next. Each time we add a slice to the out list, we decrement the count k. We basically repeat this process until the k becomes 0. So that's what I have written here. First we initialize the minimum heap and the output list, and then we create a node for the pair at index 0 in the nums1 array and 0 in the nums2 array. So that node will be added to the heap, and we mark that pair 0, 0 as visited. Next we process the nodes in the minimum heap repeatedly until we process k elements. Okay, so each iteration pop the node from the minimum heap and create a slice with the values at the pair index 1 and in nums1 array and pair index 2 in nums2 array. Okay, and add that slice to the output list. Next we try to find the next smallest pair. So we check whether the pair index 1 plus 1 is less than nums1 array size. In that case we create a node for pair idx1 plus 1 comma idx2 and then push that node into the minimum heap. Same way we check whether pair index 2 plus 1 is less than the length of the nums2 array. If that is true, then we create a node with the pair idx1 comma idx2 plus 1 and push that node into the minimum heap. Then each iteration we decrement the k. So this for loop runs until k is greater than 0, and finally we return the out list. Let's look at the flowchart. Input for the k smallest pairs procedure is nums1 array, nums2 array and integer k. Okay. First we initialize the count1 and count2 variables and minimum heap and the visited hash map and the output list variables. Okay. Next we create a node with the first element in the nums1 and nums2 array and then push that node into the minimum heap and mark the pair 0, 0 as visited. Okay. Next we enter the for loop. This for loop runs until k is greater than 0 and the minimum heap is not empty. Each iteration we pop the element from the minimum heap and assign that node to the current minimum variable and initialize the pair with the pair data present in the current minimum node. Okay, and then next we create a new slice with the values of elements referred by the node current minimum. Basically, we use the indexes in the pair and read the values from the nums1 and nums2 array and create a slice and add that new slice to the output list. Okay. Next, we check whether the pair dot index 1 plus 1 is less than the length of the nums1 array. If that is true, then we create the next pair with index 1 plus 1 comma index 2. And then we check whether that next pair is visited already. If it is not visited, then we create a new node with that next pair and then push that node into the minimum heap and mark the next pair as visited. Next, we check whether the pair index 2 plus 1 is less than the length of the second array. If that is true, then we create a next pair with index 1 and index 2 plus 1. Okay, and then we check whether that next pair is already visited. If it is not visited, then we create a new node with the next pair and push that new node into the minimum heap and mark the next pair as visited. Okay, we repeat this until the k becomes 0. Once we find the k pairs, then we come out of the loop and return the out list. Let's move on to coding. First, I define a structure pair which holds the index of an element in the nums1 array and the nums2 array. Next, I define a type node which contains the sum and then the pair. Next, I define the min heap data type, which is an array of node. Next, I write the len method for the receiver min heap. Next, I implement the method less for the min heap receiver. Then I implement method swap. Next, I implement the method top. Next, I implement the method push. Next, I implement the method pop. Next, I implement the k smallest pairs function. First, I initialize the count1 with the number of elements in the nums1 array, and then initialize the count2 with the length of nums2 array. And then I initialize the out list with empty slice and slice of int. And then I initialize the visited hash map of pair to boolean. Next, I initialize the m heap of type min heap. Then I initialize that heap. Next, I'm going to create a pair with the first elements of nums1 and nums2 array. So index 0, 0. And then I'm creating a node with the sum of the first elements in nums1, nums2 array and the pair we created just now. Next, I push the node into the min heap, and then I mark that current pair as visited in the visited hash map. Next, I write the for loop to process the nodes in the heap. This will run till k is greater than 0 and the heap is not empty. Each iteration, I pop the node from the min heap and assign that to current min variable, and then I read the pair present in that node. Then I create a slice of int with the values pointed by the indexes in the pair. and add that slice to the out list. Next I check whether the idx1 plus 1 is less than the length of the num zone array. If that is true, then I create the next pair with idx1 plus 1 and idx2. And then I check whether that next pair is already visited by checking the visited map. If that is false, then I create a new node with the next pair and the sum of the elements pointed by the indexes in the pair. Then I mark that pair as visited. Next I check whether the pair dot idx2 plus 1 is less than the length of the nums2 array. If that is true, then I create the next pair with idx1 comma idx2 plus 1. And then I check whether this next pair is already visited. If this is false, then I create a new node with this next pair and the sum of the values pointed by the indexes in the pair. Then I mark the next pair as visited in the visited hash map. Next I decrement the variable k, and then finally I return the out list as the output. Next I am going to run the test cases. Okay, there is a compilation error, a typo. Okay, let me rerun the test case. Both the tests failed. Let me take a look. I forgot to push the node into the heap. Let me do that. And for this case also I need to push the node into the heap. We need to call the pop function defined in the heap package. Let me change this. Let me rerun the test case. All the tests passed. Let me submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. So we are given the nums1 array with value 1, 7, 11 and nums2 array with 3 elements 2, 4, 6 and the k with value 3. So basically we have to return 3 smallest sum pair. Okay, so in this case 1 comma 2, 1 comma 4, 1 comma 6 are the smallest sum. So that's why the expected output is 1 comma 2, 1 comma 4, 1 comma 6. Okay, so first we initialize the count 1 and count 2. So in this case both are 3 and then initialize the out list with the empty list and the visited map with empty map and then we initialize the minimum heap. Okay, it's empty initially. Next we pick up the first element from nums1 array and nums2 array and create a node and push that into the heap. So the sum of the first two element is 3 and the pair contains the index of the first two elements. So index 0, index 0. So we get 0 comma 0. Next we mark that pair as visited. Okay, so that's why 0 comma 0 pair is marked as true. Next we enter the for loop and because k is greater than 0, so we enter, and in the iteration 0 we pop the element from the heap. So in this case it has 3 and 0 comma 0 and then we initialize the variable pair, so 0 comma 0. Okay, first we read the value at these indexes in the nums1 and nums2 array and create a slice. So in this case 1, 2, and that slice is added to the out list. So when we leave the iteration 0, so the 1, 2 is added to the slice. After adding that, next we check whether pair.idx1 plus 1 is less than count1. So in this case idx1 plus 1, 2, which is less than 3, so that is valid. So what we do is we create the next pair with the next index in the nums1 array and the same index in the nums2, 1, 0, and we check whether 1, 0 is already visited. In this case it is not already visited, so we go ahead and create a node and we push that node into the heap and mark that pair as visited. So that's why we have 9, 1, 0 is pushed into the heap and that is marked as visited. Okay. Next we check the pair index 2 plus 1 is less than count 2. In this case 0 plus 1, 2, which is less than 3. So we pick 0, 1 as the next pair. Okay. So that is the sum of that pair is 5. First we check whether that pair is already visited. In this case it is not yet visited. So we added 0, 1 and mark that as true and then push that node into the heap. So when we leave the iteration 0, we have nodes which contains the pair that will give us the next smallest sum. Okay. So in this case 0, 1 and 1, 0. Okay. And in the iteration 1, we pop the minimum element from the heap. So in this case we get 5, 0, 1. So we create a slice with the value at index 0 in nums1 and index 1 in nums2 array, which is 1, 4. That gets added to the out list. After adding 1, 4, next we try to find the next small pairs that can give us the smallest sum with respect to the current pair 0, 1. Okay. So first we check whether the 0 plus the pair idx1 plus 1 is less than count1. In this case 0 plus 1 is less than 3. So we go ahead and check whether the 1, 1 is already visited. Okay. So in this case it is not yet visited, so we go ahead and mark that as true and we create a node for that pair 1, 1 and push that into the heap. Okay. Next we check whether the pair index 2 plus 1 is less than the size of the second array. In this case 1 plus 1, 2, which is less than 3. So we go ahead and create a pair 0, 2 and push that into the heap. So we get 7, 0, 2 and mark 0, 2 as visited. Okay. After that we decrement the value of k. So now the value of k is 1. And in the iteration 2, we pop the minimum element from the heap, which is 7, 0, 2 pair. Okay. And read the value at index 0 in nums1 array and index 2 in the nums2 array and add it to the out list. So the out list now have 1, 6. After adding that, we try to find pairs that can give us the next smallest sum. So in this case pair idx1 plus 1, which is 0 plus 1, which is less than 3. So we go ahead and create a pair 1, 2. Okay. We create the node for that pair and push that into the heap. Next we check the pair dot idx2 plus 1. In this case the idx2 is index 2. So 2 plus 1, 3, which is not less than 3. So we are not adding this pair. And then we decrement the value k. Then next we decrement the value k and now the k becomes 0. Because it is 0, we break out of this for loop. And then finally we return the out list. Now the out list has 1, 2, 1, 4, 1, 6. That is an expected output. Next, I'm going to do the time and space complexity analysis for this solution. The time complexity of this procedure is order of m times n times log m times n. Okay. So we need to perform 3 times k plus 2 heap operation to solve this problem. So if you look at this for loop, each iteration we perform 1 pop operation, 2 push operations. Okay. So each iteration 3 operations we are performing. So totally 3 times k, plus in the last iteration, even though we are not using the next pairs, we still push that element. So that's why 3 times k plus 2. Okay. And in a heap of size k, each operation costs order of log k time complexity. Okay. So the total time complexity in this case is k times log k, because we removed the constant factor out of this, so we just pick only k. That's why k times log k. And in the worst case scenario, the value of k is equal to m times n. So that's why the time complexity is order of m times n times log m times n. And the space complexity is order of m times n, because we need to store the k pairs in the heap and also in the hash map. So the worst case, the value of k is equal to m times n. That's why the space complexity is order of m times n. Thanks for watching this video. Have a great day.